right, this section is on quadratic functions and their properties. So it is important to know how to be able to do these properties by hand, and that's what we're going to go over. So the first thing we want to just take notice of at the top here is our quadratic function. You have f of x equals ax squared plus bx plus c. And in vertex form, which we will be using today, we have f of x equals a times x minus h squared plus k, where your vertex is h and k. The graph of the function is called a parabola. Hopefully that's something you remember from Math 1, Math 2, and Math 3. Our characteristics of a parabola. So if a is positive, greater than 0, then your parabola opens up, so it's going to look sort of like a U. If a is less than 0, meaning negative, the parabola opens downward, meaning it's going to look kind of like an N. Your axis of symmetry can be found by using the formula negative b over 2a. This is kind of like an imaginary line that goes through your graph, where it would be, where if you fold it, it would line up. It would be symmetric. So to get your vertex, you take your axis of symmetry, whatever you get for your axis of symmetry, and you plug it back in to the function and solve. And there you will get a point, and that will either be the very top of your parabola or the very bottom of your parabola. Make sure to write this as an order pair. Your y-intercept is 0c. C is just the constant in your function, and your x-intercepts. So you can look at this and tell if you have 1, 2, or no x-intercepts, depending on if the determinant equals 0 or is positive or negative. Another way is to look at your graph. If you know where your vertex is, and if it opens up or down, you can kind of tell whether it's going to have any x-intercepts or not. So let's look at the first example together. So we're going to find the direction of the opening, axis symmetry, the vertex, y-intercept, x-intercepts, and then we're going to sketch it. Okay, so first of all, looking at this, we see that this is positive, positive 3. Therefore, it opens up. For part B, our axis is symmetry. So remember that formula is negative b over 2a. So we'll have negative, and then our b is actually negative 6 over 2 times a, which is 3. So we get 6 over 6, which is 1. So axis of symmetry is 1. Now so the axis of symmetry is not an official part of the graph, but I like to sketch it in because it gives me a good idea of how my graph is going to line up. And so that's x equals 1. Okay, so then for part C, if we're looking for the vertex, we're going to take the 1 that we just got and we're going to plug it back into our function. So 3 times 1 squared minus 6 times 1, and that should give us negative 3. And remember, this is a point, so we plugged in 1 for the x, and we got out negative 3. And we'll go ahead and plot it. Okay, part D, the y-intercept. So the y-intercept is just 0c. Well, there is no c. There is no constant. So that means it's 0. Or there is a constant. It's 0. So there's our y-intercept. So I'm going to also go ahead and plot it. Okay. All right, if we think about our x-intercepts, we can see where our vertex is and it opens up. So we know that it's going to cross the x-axis. So in order to find those x-intercepts, we take 3x squared minus 6x and set it equal to 0 and solve. So I'm going to start by factoring. I'm going to factor out a 3x, which leaves me with x minus 2. And if I set each equal to 0, here I have to divide by 3, x equals 0. So one intercept is at 0, 0. Here, if I add the 2, I'll get x equals 2, so my other intercept is at 2, 0. So I've already got 0, 0 plotted. I'll plot 2, 0, and now I just draw my parabola. Hopefully yours looks a little better than mine. All right, let's do a couple more examples. All right, so for B, we can see here that we have a negative with the x squared, so that means it is going to open down. For part B, our axis is symmetry. X equals B is 3, so I have a negative, and I'm plugging in a 3 over 2 times A, and A is negative 3. And so that's going to simplify into a positive 1/2. So I'm just going to write that as x equals 1/2. And if I draw my dotted line here, I know that that's my symmetry. X equals 1/2. Then for part C, to get my vertex, I'm going to plug in 1/2. So negative 3 times 1/2 squared plus 3 times 1/2 minus 2. And with that, we get negative 5 over 4. So I would write that as a point, as a coordinate. And if I go ahead and plot it, it's going to be about right here. Part D, we're doing our y-intercept, so that's going to be 0, negative 2. Forgot my parentheses. Okay. Now, if we try to figure out our x-intercepts, we look at that and we see where our vertex is. We already said it's opening down, so if it opens down, then it's not going to cross the x-axis. So there are no x-intercepts. And I can use my axis of symmetry to get this point right here because it's going to be even on the other side. It's going to be just reflected. And then I can sketch my parabola. All right, on C, if I look here, I see that that's positive, therefore it's going to open up. If I do my axis of symmetry, I have negative, and then B is negative 8 over 2 times A, which is 3. So that's going to be 8 over 6, which reduces to 4/3. So my axis of symmetry is going to be about right here, 1 1/3, or 1.3. Okay. Then for part C, if I plug in 4/3, so 3 times 4/3 squared minus 8 times 4/3 plus 2. And that's going to give me negative 10/3. So again, we write this as a point. And I'm going to plot that on our graph. So that's going to be about 3.33, or sorry, negative. So it'll be about right here. My y-intercept is 0, 2. So up here is where it's going to be. Now my x-intercept, what I would do, I know I can already see it's going to cross the x-axis. Okay, so I need to take the 3x squared minus 8x plus 2, set it equal to 0 and solve. Normally we would factor, but this one can't be factored. So we are going to use quadratic formula. So we have negative b is negative 8, plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is 3. Now, if I simplify that, I'll get 8 plus or minus the square root of 40 over 6. Now, if I break down 40, remember when you simplify square roots, you want to think of two numbers that multiply to be 40 where one of them is a perfect square. So that would be 4 and 10. and then you take the square root of the one that's actually a perfect square. So the square root of 4 is 2. It comes to the outside, and 10 stays in the radical. And then we have 6 on the bottom. Okay, we can simplify this yet again because 8, 2, and 6 are all divisible by 2. So if I reduce all those by 2, I will get 4 plus or minus the square root of 10, because 8 divided by 2 is 4, 2 divided by 2 is 1, so there's nothing in front of that 10, square root of 10 anymore. 6 divided by 2 is 3. And now I'm going to go ahead and write this, so this will give me my x-intercepts. So that would give me 2 x-intercepts. I'm going to go up here. So I have a 4 plus square root of 10 over 3. Oh, write that as a coordinate. Whoops. Comma 0. And then we have 4 minus square root of 10 over 3. Now, you can just type those in your calculator to get those decimals to kind of figure out where they're going to be on your graph. So we get about 2.4 and about 0.4. So we connect those to get our parabola. Okay, find the equation of a parabola given a point and the vertex, and we'll write our answer in standard form. So being that we're given a vertex and a point, I'm going to start off with vertex form. So remember, vertex form looks like this, and this was on the front side of your page. So that's vertex form. So I'm going to plug this in first. So x minus 2 squared plus 1. Now, the reason they give us a point is so that we can figure out what a is. So I'm going to plug these in for x and y. So I have 5 equals a times 0 minus 2 squared plus 1. So 0 minus 2 is negative 2. Negative 2 squared is going to be a positive 4. So I have 4a plus 1. If I subtract the 1, I'll get 4 and divide by 4. So I get a is 1. So what I'm going to do is I'm going to go back here and rewrite it in that form. So I have f of x, and there's just a 1 on the outside, which we're not going to put that 1. So x minus 2 squared plus 1. Now, it tells us to write it in standard form, which means we need to simplify this. Remember that some stars don't always shine to help us with squaring of this. So I'm going to square the first. Same sign, double the product. My product is 2x. If I multiply those two, if I double it, I get 4x. Always plus square the last. And then I have the minus 1 on the end, and I'll combine those two to get x squared minus 4x plus 5. Okay, so one more like this. If I first plug it into vertex form, I have a times x minus negative 2, which those two negatives are really going to turn to a plus, and then plus 6. So then I'm going to plug in my point. So I have my y is negative 2. I don't know my a. My x is negative 4. So negative 4 plus 2 is negative 2. Negative 2 squared is going to give me a 4a plus 6. If I subtract 6 from negative 2, I get negative 8. And if I divide by 4, I get negative 2. So I'm going to go back, and plug it in there. So I have negative 2, x plus 2 squared plus 6. So again, I'm going to square this using my some stars don't always shine. Keeping that negative 2 up front. We're not ready to use it quite yet. Square the first, same sign. If I double my product with these two is 2x. If I double it, I get 4x. Always plus, square the last. Then I'm going to distribute my negative 2. So negative 2x squared minus 8x minus 8 plus 6. And I can combine my like terms. Negative 2x squared minus 8x. And that's going to be minus 2 for standard form. And that concludes this section.